Hello viewers, this is Ronald taking you through the tutorial for A-level applied mathematics. In this video, I'm going to go through the topic of binomial distribution. This topic is under probability and is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So a random variable capital X follows a binomial distribution as long as these 5 conditions are satisfied. One is that there should be a fixed number of trials and is denoted by small n. 2 is that each trial involves either a success or a failure. Then 3 is that all the trials are independent. Then 4 is that the probability of success, so the probability of success is noted by a symbol small p, is the same in each trial. And lastly is that the variable is the total number of successes in the n trials. So we shall see what all these ones mean as we go forward. So first we shall start with what we call the binomial formula. So the binomial formula says that if capital X follows a random variable which is binomially distributed, so this B denotes binomial distribution, N denotes the number of trials, and P denotes the probability of success. Therefore, this one means that X follows a random variable which is binomially distributed with N trials and probability of success P. So as long as you see capital B here, just know that this random variable is a binomial distribution. So that means that the probability of X equal to R will be given by the formula N combination R multiplied by P to power R multiplied by Q to power N minus R. So this formula is a standard formula and is also available in the mathematical tables. So I believe you have those mathematical tables with you. So the formula we shall be using more frequently, so you have to know how to state it. Then another one is the formula for mean. So mean or expected value of X is given by NP, where N is the number of trials and P is the probability of success. Then variance over X is given by NP Q, so all is the product. So P is the probability of success, Q is the probability of fail, N is the total number of trials, R is the number of times a success occurs. So note this one, that N is the total number of trials, but R is the number of times a success occurs. And capital X is the random variable that a success occurs. So with that, we shall go through these questions and see how to use the binomial formula to get the required probability and also to get the mean and variance. So we have these parts: part A, part B, part C, and part D. So we'll start with part A. So part A, Roman 1, first of all you have to know that from the formula N is 5, P is 0.75, and Q can be calculated because Q is equal to 1 minus P and 0.25. Then from there they wanted probability of X equal to 3, so you have to remember the binomial formula that R is 3 and N is 5. Then P is 0.75, Q is 0.25, then this 2 is N minus R, so 5 minus 3 gives you 2, which is there. So in the end we shall come up with 0.26367. Then Roman 2, the probability of X greater than or equal to 3. So greater than or equal to 3 means that you start from 3 up to the end. Now how do you know where to stop? Where to stop depends on the value of N. So it means that the variables will be 3, 4, and 5. That is why you see here that this probability is expanded as probability of X equal to 3 plus probability of X equal to 4 plus probability of X equal to 5. So from there we shall use the binomial formula for each probability. So this is for this probability, and this is for this probability, and this is for that probability. After that, we shall use the calculator to come up with 0.89648. The Roman 3, they wanted the mean, so mean is NP, so N was 5, P is 0.75, therefore we come up with 3.75. And lastly, the variance is NP2, so N is 5, P is 0.75, and Q is 0.25, you come up with 0.9375. So that was part A. Now we shall go to part B. So for part B, N is 4, P is 0.6, and Q is 0.4. Therefore, they wanted the probability of x equal to 0. That means that R is 0, N is 4, therefore P is 0.6, R is 0, Q is 0.4, and this one is N minus R, therefore 4 minus 0 gives 4, which is there. So in the end, we shall come up with 0.0256. Now we shall go to Roman 2. Roman 2, they wanted the probability of x less than 1. So x less than 1 is only 0. Therefore, the probability of 0, we have already got it here. So the answer will be 0.0256. Then Roman 3, they wanted mean. Mean is NP. N is 4 and P is 0.6. So you come up with 2.4. And lastly, variance is NP2, so N is 4, P is 0.6, and Q is 0.4. You come up with 0.96. So now we shall go to part C. So part C, N is 12, P is 0.55, Q is 1 minus P, which is 0.45. They also wanted the probability of x equal to 9, so you substitute into the binomial formula. R is 9, N is 12, P is 0.55, Q is 0.45. Now this 3 is N minus R, therefore 12 minus 9 gives 3, which is there. In the end, it will come up with 0.09233. Now we shall go to Roman 2, where they wanted the probability of x greater than 8. Now greater than 8 means you start from 9, 10, 11, 12. So you stop at 12 because our N is 12. Therefore, we shall use the binomial formula for each probability. For this one, this is the binomial formula. For this one, that's the binomial formula. For this, the binomial formula is that. And for this, the formula is that. So when you use the calculator, we shall come up with our probability being equal to 0.13557. Now we shall go to mean. Mean is NP. N is 12, P is 0.55, so you come up with 6.6. And lastly, variance. Variance is NP2. N is 12, P is 0.55, Q is 0.45, so you come up with 2.97. So lastly, we shall go to part D. Part D, N is 15, P is 0.85, Q is 1 minus P, which is 0.15. Therefore, they wanted a probability of x equal to 13. That means that R is 13, N is 15, P is 0.85, Q is 0.15. Now this 2 is N minus R, therefore 15 minus 13 gives you 2. That is why there is 2 there. So in the end, we shall come up with 0.28564. Roman 2, they wanted the probability of x less than 13. Now x less than 13, the complement of x less than 13 is x greater than or equal to 13. Now we are using complement because this inequality x less than 13 has a lot of values, because it has 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. But the complement is the one is the opposite of what they want of this inequality, and that is 13, 14, and 15. Now since this is complement has smaller values, that means that it is easier if we use the complement law. Complement says that a probability of a plus probability of a complement is equal to 1. Therefore, this probability is equal to 1 minus probability of its complement, which is x greater than or equal to 13. Therefore you come and substitute. This one gives you 13, 14 and 15. Binomial formulas are those. So this is for 13, this is for 14, and this is for 15. Now next is to use a calculator to come up with 0.39578. And Roman 3, they wanted mean, so mean is NP, N is 15, P is 0.85 to give you 12.75. And lastly, variance is NP2, N is 15, P is 0.85, and 2 is 0.15, which is 1.9125. So now that we have learned how to use the binomial formula to get the probabilities, mean and variance, we shall now go to the other parameter, which is mode. Now for a binomial distribution, mode is the value of x with the highest probability. Now since there are many values, for you to know which value is that, you have to remember that that mode is closer to the mean. Therefore the value is an integer. Note this word integer, close to the mean. Therefore if the mean of x is an integer, it implies that that very value becomes your mode. But if it is not, you have to remember that it is if mean is not an integer, it implies that the mode is closer to that mean. So we shall see how to get it in case mean is not an integer. Then next we shall go to what we call the binomial probability distribution table. So this is a table used to obtain the probabilities in the form probability of x equal to r. So in the previous slide we have seen how to calculate the probability of x equal to r using the binomial formula, but sometimes you can easily get this probability using the binomial distribution table. So this one is also, the table is also available in the mathematical logbook. So these are the questions, part A, part B, part C, and part D. So we shall see how to get these probabilities for each part using the binomial distribution table, and also how to get mode for each part using this knowledge. So we shall start with part A. Part A says that if x follows a binomial distribution with number of trials 5 and probability of success 0.25, find Roman 1 probability of x equal to 3 and Roman 2 the mode of x. So what you should remember is that n is 5 and p is 0.25 and r is 3. So with that knowledge we can now go and use our binomial distribution table. So if you come at the binomial distribution table, this is n, so you look for 5, which is this. Then r, they said 3, which is this. Then the probability of success, so from here up to here, these are values of the probability of success. So probability of success was 0.25. Now the intersection is what becomes the probability of interest. So the probability of interest is, now these are 4 digits, so probability must be to 4 decimal places, therefore it will be 0.0879. Therefore shall come here and say that the probability of x equal to 3 is equal to 0.0879, as simple as that, and we're done. Then for Roman 2, you must remember that the mode is closer to the mean, so the first thing to do is to calculate the mean. So n is 5, p is 0.25, and then you come up with mean as 1.25. Now mean is not an integer, meaning that the mode is closer to that mean and it's a whole number. So you ask yourself, this 1.25 is enclosed by which is between which two integers? This 1.25 is between 1 and 2. Therefore you are going to get the probability of x equal to 1 and the probability of x equal to 2, and look at the one with the highest probability. So when you do that, you shall come here and say that probability of x equal to 1 is this. then the probability of x equal to 2 is this. So probability of x equal to 1 is 0.3955, and probability of x equal to 2 is 0.2637. Therefore, shall come here and write them down. The probability of x equal to 1 is 0.3955, probability of x equal to 2 is 0.2637. Then you ask yourself, of these two probabilities, which one is higher? So the one which is highest is 0.3955, and that means that the corresponding value of x is what will become our mod. Therefore, shall come and conclude that mod is equal to 1. So basically that's how they get mod in case mean is not an integer. So that was part A. Now part B, if you look at this, part B says that if x is the binomial distribution with n equal to 4 and p equal to 0.4, find Roman 1 probability of x equal to 1 and Roman 2 the mod of x. So we know that n is 4 and p is 0.4, then r is 1. Therefore, shall come back here and go to our table and look for n, which is 4, then r, which is 1, and p, which is 0.4. So the intersection is what becomes our probability of interest. So 4 degrees, meaning that probability is 0.3456. Therefore, shall come here and say that now the probability which is required is 0.3456, as simple as that. Then next we have to first calculate the mean. So mean is 1.6. It is also still not an integer, meaning that the mod is just close to the mean. Now this value 1.6 is enclosed by two integers, and those integers are 1 and 2. Therefore, still we shall get the probability of 1, x equal to 1, which is, so we shall come here and look for it. So probability of x equal to 1 is this one, which we already got, and probability of x equal to 2 is this one. I think we realize that both probabilities are the same. So when they're the same, what does it mean? It implies that the mod is equal to 1 and 2. In other words, both values are equal to the mod. So that was part B. Now part C says if x is the binomial distribution with n equal to 12 and p equal to 0.5, find the probability of x equal to 8 and the mod of x. So here you should realize that n is 12, p is 0.25, and r is 8. So shall come here and look for that probability. So n is 12, then r is 8, and p is 0.5. So the intersection is this, which is 0.1208. Therefore, shall come here and say that the required probability is 0.1208, as we have got it here. Then shall go to part B. First thing to do is to calculate the mean. So in this case, the mean is 6, implying that the mod is 6 because mean is an integer. Now shall go to part D. So part D says that if x is a binomial distribution with n equal to 15 and p equal to 0.35, find Roman 1 probability of x equal to 6 and Roman 2 the mod of x. So here you must realize that n is 15 and p is 0.35 and r is 6. So shall come here in our table and look for n, which is 15, then look for r, which is 6, and look for p, which is 0.35. So the intersection is that one, which is 0.1906. So what does that mean? It it means that the probability is 0.1906. So now we shall go to Roman 2. Roman 2, the first thing to do is to calculate the mean. Now mean is not an integer, meaning that the mode is closer to the mean. Therefore, this 5.25 is enclosed by two integers, and those are 5 and 6. Therefore, we shall look for the probability of x equal to 5 and probability of x equal to 6. The one for x equal to 6 has already been got here, so the next thing to do is to get the probability of x equal to 5. So x equal to 5 is 0.2123. So shall come here and state that x equal to 5 is 2123 and x equal to 6 is 0.1968. Therefore, the one the highest probability is x equal to 5. Therefore, mod is equal to 5. So now shall go to cumulative binomial distribution table. So the binomial distribution has two tables. One is just binomial distribution table, and another one is cumulative. So you must be keen of that word cumulative. So what is the difference? This table is used to obtain probabilities in the form x is greater than or equal to r. Now remember, the binomial probability distribution table is used to obtain probabilities of x equal to r. But now when there is the word cumulative, it implies that the probabilities you'll be reading will be x greater than or equal to r, where r is an integer and it takes on the format similar to that of the binomial distribution table, but it's used to obtain probabilities only in the form x greater than or equal to r. So always remember that. Therefore, in cases where the question is not in this form, it implies that you have to first express it in this form before you use the binomial distribution table. For example, if the probability is x less than r, you remember that this one is the same as x greater than or equal to r. Then if the probability is x greater than r, it implies that this is the same as the probability of x greater than or equal to r plus 1. And if the probability is x less than or equal to r, it implies that the complement will be x greater than or equal to r plus 1. Therefore, that's why you put here 1 minus this probability of x greater than or equal to r plus 1. So with that knowledge, you shall now go and do this question. So question 3, that is part A, part B, part C, and part D. So we are going to answer all the parts. Let's start with part A. So part A, x is a binomial distribution with n5 and p 0.25, and r is 3. Therefore, shall come here and say that first of all you must look at this word cumulative binomial distribution table. So if you have forgotten the sign is also here at the heading of the table, that greater than or equal to r. So our n is 5, r is 3, and p is 0.25. Therefore, the intersection is 0.1035, and that will be our probability. So shall come here and state that the part A, the probability is 0.1035. Then when you go to part B, the one with the probability of x less than or equal to 1. Now this one is not in the form of greater than or equal to, so the first thing to do is to express it in that form, as we already seen in the previous slide. So in this case now, r is 2 and n is 5, p is 0.4. So shall come here and look for those values. N is 4, r is 2, and p is 0.4. The intersection is 0.5248. So shall come here and say that this probability is 0.5248. Therefore, when I subtract, I come up with 0.4752 as the required probability. Next, we shall go to part C. Part C still we have to express in the form of greater than or equal to. So x greater than 8 is the same as x greater than or equal to 9. And when you use the table, R is 8, R is 9, because when you look at here, R is 9 here. So R is 9, N is 12, and P is 0.25. The probability is, I think you realize that there is a 0 here. Don't just remove it, just say that the probability is 0.0730. The next we shall go to part D. So part D still we have to express in the form of greater than or equal to. So this one is the same as 1 minus probability of x greater than or equal to 6. So R is 6, N is 15, P is 0.35. So R is 6, N is 15, P is 0.35. The probability is 0.4357. Therefore, you shall come here and say that the probability, this one is 0.4357, and when I subtract, I come up with 0.5643. So now we shall go to the next part, which is binomial distribution in real life. So in this part we shall go through a number of questions which have been set in the previous past papers of UNEB. So we shall start with question 1, which came from UNEB 2012 paper 2 question 15a, and it says a box of oranges contains 20 good and 4 bad oranges. If 5 oranges are picked at random, determine the probability that 4 are good and the other is bad. So this is a binomial with n equal to 5 and p is the probability of getting a good orange. So there are 20 good and the total is 24 because this is 20 plus 4. Therefore, probability of getting a good orange is 20 over the sample space, which is 24. When I reduce it, will be 5 over 6. Then now that I've got p, I can get q from 1 minus p, which gives you 1 over 6. Now, since this probability of success is not there in the binomial distribution table, we have to use the formula. So the probability of x equal to 4, we shall use the formula, which is 5 combination 4 multiplied by p raised to the power 4 multiplied by q raised to the power n minus r. Now n minus r, 5 minus 4 gives you 1. That is why here it is power 1. So even if we don't put the power 1, it still remains the same. Therefore the answer will be 0.40188. And basically that's what they wanted. So B1 for getting this probability of success, M1 for the substitution in the binomial formula, A1 for output. Now we shall go to question 2, which came from UNEB 2018 paper 2 question 8, and it says a biased coin is such that a head is 3 times as likely to occur as a tail. The coin is tossed 5 times. Find the probability that at most 2 tails occur. So the first thing to do is to get the probability of success. So we shall say that let pt be equal to t. The probability of a tail is t. That means that the probability of a head is 3t, because they told us 3 times as likely to occur as a tail. So if the probability of getting a tail is t, it implies that the probability of getting a head is 3 times that for a tail. That is why there is 3t. Then after that, remember that total probability is equal to 1. Therefore t is equal to a quarter, implying that p is a quarter, because the probability of success is the probability of getting a tail. Then q is 1 minus p, which is equal to 0.75, and n is 5 because it was given here. Therefore shall come and say that let x be the random variable which follows the binomial distribution with n equal to 5 and p equal to 0.25. That means that probability of at most 2 tails is equal to probability of x less than or equal to 2 Now less or equal to 2 is equal to x equal to 0 plus x equal to 1 plus x equal to 2. So from there we can use now the binomial distribution table, because this probability of success is available in that binomial distribution table. So when we come here and open this table, we shall look for n, which is 5, and p, which is 0.25. Then we want the three probabilities: x equal to 0, x equal to 1, and x equal to 2. So x equal to 0 is 0.2373, x equal to 1 is 0.3955, x equal to 2 is equal to 0.2637. So I'll come here and add all those ones and come up with 0.868965, and basically that's what they wanted. So M1 is for this adding up all these probabilities, B1 is for reading this first probability, B1 for reading the second probability, B1 for reading the third probability, and A1 is for the output. That was question 2. Now we shall go to question 3, which came from UNEB 2017, paper 2, question 2. And it says, the probability that a patient suffering from a certain disease recovers is 0.4. If 15 people contracted the disease, find the probability that A, more than 9 will recover, and B, between 5 and 8 will recover. Now this is a binomial with n trials, which is 15, p is 0.4, and q is 1 minus p, which is 0.6. The probability of more than 9 means is the same as x greater than 9, which is equal to x greater than or equal to 10. And when I use the cumulative binomial distribution table, I'll come up with R is 10, n is 15, p is 0.4, so the probability is 0.0338. That is why there is 0.0338 here. Then part B, they wanted the probability between 5 and 8, that is x greater than 5 but less than 8. And the integers in between, there is 6 and 7, that is why there is probability of x equal to 6 plus probability of x equal to 7. Therefore, I can now go to the table of now binomial distribution table, not cumulative. In part A we use cumulative, now we are using binomial distribution. So n is 15, r is 6 and 7, and p is 0.4, so the probabilities are 0.2066 and 0.1771. When I add the two, I come up with 0.3837, which they want. So M1 is for writing this expression and A1 is for the output. M1 is for this addition, B1 for the table values, and A1 is for the output. So that was question 3. Now we shall go to question 4. So question 4 came from UNEB 2014, paper 2, question 4, and says Tom's chance of passing an examination is 2/3. If he sits for 4 examinations, find the probability that he passes only 2 examinations, and part B, more than half of the examinations. So in this case, this is the binomial. P is 2/3, therefore Q will be 1 minus P, which is 1/3, and N is 4. The probability of only 2 is the same as exactly 2, which is x equal to 2. There we shall use the binomial formula because this probability of success is not there in the mathematical table. So the output will be 8/27. Then for part B, more than half, it means more than greater than 2, which will be 3 and 4. Therefore we shall use the binomial formula still and come up with the required probability as 16/27. So basically that's what they wanted. M1 for the substitution, A1 for the output, M1 for the substitution, and B1 for the addition, A1 for the output. So that was question 4. Now we shall go to question 5, which came from UNEB 2006, paper 2, question 3, and says J1 played 12 chess games. The probability that she wins a game is 3/4. Find the probability that she will win Roman 1 exactly 8 games and Roman 2 more than 10 games. So this is still a binomial distribution with n 12. P is 3/4 and Q is 0.25. Therefore, probability of exactly 8 is x equal to 8. So here we use a binomial formula because this probability is outside the range, and the output will be 0.19358. Then part B, more than 10 is x greater than 10, which will be 11 and 12. Therefore, we shall use the binomial formula to come up with the required probability as 0.15839. So basically that is what they wanted. M1 will be for this substitution, A1 for the output, M1 for this substitution, B1 for the addition, and A1 is for the output. So that was question 5. Now we shall go to question 6, which came from UNEB 2001, paper 2, question 4, and says a coin is biased so that a head is twice as likely to occur as a tail. If the coin is tossed 15 times, determine Roman 1 the expected number of heads and Roman 2 the probability of getting at most 2 tails. So the probability of head is twice, so if the one for tail is x, the other one will be 2x. But we know that total probability is equal to 1, therefore x is 1/3. Therefore probability of success is 2/3, probability of fail is 1/3, and n is 15. So B1 is for getting the probability of success. Now we shall go to Roman 1, where they wanted the expected number. So expected number is given by NP. N is 15, P is 2/3, therefore you come up with 10. Then Roman 2, they want the probability of x less than or equal to 2, which is 0 and 1 and 2. Therefore when I substitute using the binomial formula, I'll come up with that, and when I use the calculator, I'll come up with my probability of 0.07992. So basically that is what they wanted. Now let's see how much can be awarded. M1 substitution, A1 output, substitution, output. So that was question 6. Now we shall go to question 7, which came from UNEB 2001, paper 2, question 10b, and it says a fair die is rolled 6 times. Calculate the probability that Roman 1 a 2 or 3 appears on the first throw. Then Roman 2, 4 5s will appear in 6 throws. So now still this is a binomial distribution with n is 16. Therefore the probability of 2 or 6 the same as O is a union, therefore it will be probability of 2 plus probability of 4 minus the intersection. But the intersection is 0 because the 2, you can't get a 2 and a 4 at the same time of throw. Therefore the probability of getting a 2 is 1/6, probability of getting a 4 is 1/6. Therefore when you add the 2 minus 0 to be 1/3. Then part B, it becomes a binomial with, they said 4 5s. Now 4 5s means that the number of 5s are being got 4 times. That is why you see x equal to 4. And the probability of getting a 5 is 1/6. That is why you see a probability of success as 1/6. And probability of fail as 5/6. And this one is n minus r, so 6 minus 4 is 2. Therefore now use the calculator, I'll come up with 125 over 15552, and basically that is what they wanted. So B1 is for identifying this, that the intersection is 0. M1 is for substitution, A1 for the output, M1 for substitution, A1 is for the output. That was question 7. Now we shall go to question 8, which came from UNEB of November 1998, paper 2, question 5. And it says, the probability that Bob wins a tennis game is 2/3. He plays 8 games. What is the probability that he wins at least 7 games and exactly 5 games? So this is the binomial distribution. P is 2/3, Q is 1/3, N is 8. Therefore, probability of at least 7 games is x greater than or equal to 7, which is 7 and 8. Therefore, we shall substitute using the binomial formula, and then after that, you shall use the calculator to come up with 128 over 6561 as our probability. Then Roman 2, exactly 5 games, we shall still use the binomial formula to come up with 1792 over 6561, and basically that is what they wanted. So M1 is for these substitutions, and M1 is for the addition, and A1 is for the output after addition. Then M1 for substitution, A1 for the output. So that was question 8. Now we shall go to question 9, and say that it came from UNEB, March 1998, paper 2, question 12A, and it says, a pupil has 10 multiple choice questions to answer. There are 4 alternative answers to choose from. If a pupil answers the questions randomly, find the probability Roman 1 that at least 4 answers are correct, and Roman 2 the most likely number of correct answers. So Roman 1 at least 4, this is the binomial. N is 10, P is a quarter, and Q is 0.75. The probability of x greater than or equal to 4, this here we shall use the cumulative binomial distribution table. So R is 4, N is 10, P is 0.25, so the probability is 0.2241. Then for part B, most likely number is another word to mean mod of x. Therefore, the first thing to do is to get the mean, and that mean is enclosed between 2 values, x equal to 1, 2, and x equal to 3. If you look at this, x equal to 2 is 0.2816, and x equal to 3 is 0.2503. Of the 2, this is bigger, therefore mod or most likely number is 2. Basically, that's what they wanted. Now let's see how much can be awarded. So B1 for this table value, B1 for mean, B1 for this, B1 for this, and B1 for that. So that was question 9. Now we shall go to question 10, which came from UNEB 1997, paper 2, question 7, and says that the probability of winning a game is 4/5. 10 games are played. What is the probability? What is Roman 1 the mean number of successes, and Roman 2 the variance, and Roman 3 the probability of at least 8 successes in the 10 games? So Roman 1, they want the mean. Mean is NP, therefore you come and say that mean is N is 10, P is 0.8, therefore the mean is 8. Then the variance is NP2, N is 10, P is 0.8, Q is 0.2, therefore the variance is 1.6. Then Roman 3, they want the probability of at least 8 successes. So B1 for mean, B1 for variance. So that is probability of x greater than or equal to 8, which is x equal to 8, x equal to 9, x equal to 10. Then we shall use the binomial formula, and after that we shall use the calculator come up with the probability as 0.6778. So basically that is what they wanted. M1 is for these substitutions, this and that. Another M1 is for this addition, and A1 is for the output. Now, like I've already said, the content on this platform is basically from the books we have already written. So this content from Math Paper 2 is got from this book, Mastering A-Level Mathematics Paper 2, and also from the Mathematics Question Bank, where questions are arranged topical. So we are working on a project whereby we want to convert our hard copy books into video lessons. So content from Math Paper 2 is got from there. Content from Math Paper 1 is got from Mastering A-Level Mathematics Paper 1, and also from the Question Bank. I think you can see that it has both questions for Paper 1 and Paper 2. Then for Physics, Paper 1 is got from there. Physics Paper 2 is got from there. O-Level Physics for Senior 1 and Senior 2 is got from there, and O-Level Physics for Senior 3 and Senior 4 is got from there. Sub-Math is got from this book, and O-Level Math is got from there. So these books are available in stock. Therefore, if you need any of the copies, you can contact the author on the WhatsApp or call of +256 704 989851. And that brings us to the end of this video. Thank you for watching, and be reminded that next video will be on continuous random variables. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on continuous random variable has been uploaded. Otherwise, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that you can all benefit as a family.